It's good to see lots of people interested in learning a little bit more about citizen science, which is this tool is gaining popularity every day as a means of analyzing data. And in fact, on that note, I realized as I was writing this talk that I actually have to correct this first slide straight away. It's even more popular than it used to be. And the fact that that number has gone up, hopefully I'll talk about that more during the rest of this presentation. So first of all, let me just introduce myself. You might be wondering, like, who is this guy? Why should I listen to what he has to say about citizen science? Well, the truth is, I actually don't know anything about the food system, really. My day job is as an astronomer. And as an astronomer, I study galaxies in the distant universe. So I look at images like this. And the first thing you can probably tell about this image is it's a pretty complex image. There's lots of stuff going on in that image. And in the process of analyzing data like that, I actually have to work with really, really big data sets. So to get that image, we use telescopes that look a bit like this. This is a telescope that actually hasn't been launched yet. But this telescope will take images of 1 billion galaxies. Okay, so we need to be able to analyze 1 billion images. And that's not particularly difficult. I mean, these days, 1 billion isn't a huge number, but when you add to that the fact that you need to analyze those images in a complex way. So I need to be able to not just tell the difference between the two galaxies on the left-hand side, which is quite easy to do. I also need to be able to tell the difference between the two objects on the right-hand side. So one of those is a galaxy, but the other one isn't a galaxy even. And turns out that's really difficult to do in an automated way. And so a lot of the time that I spend doing my work, I'm actually doing data science to try and understand how those data behave, and also doing machine learning to try and analyze those data and try and come up with very complicated models so that I can extract information from very complicated data. And it's turned out over the last few years that actually all of those things can be solved to a certain extent by this amazing tool called citizen science. Which kind of begs the question, what is citizen science? Or more specifically, what do I mean by the word citizen science in the context of what STFC do, and therefore in the context of this webinar? And I wanted to get this out of the way quite early, because often people who work in different fields of science, they have a different idea about what citizen science means. So I've made this slide, which is a very limited taxonomy of the different types of citizen science. So on the left-hand side, you have this idea of co-created citizen science, which I think is what a lot of people have in their minds. It's where professional scientists and citizen scientists, so non-experts, they collaborate at all levels of the scientific process. So they do things like they decide what topics are worthy of investigation. And then the citizens themselves will help to design the experiments that they're going to perform. They will perform those experiments, so they'll be collecting the data, and they'll be analyzing it, and sometimes they even help to write the papers and disseminate the results. And ultimately, they're the end users of the data. They really are stakeholders that are involved at all levels of the process. Since the invention of the World Wide Web, another type of citizen science has become more common, and that's the middle way, if you like, which is called contributory citizen science normally. And in that case, what happens is the professional scientists take on the role of identifying the thing that they want to investigate. So they decide that this is an interesting topic, but it's difficult for us to investigate by ourselves because there's a large amount of data, or it's a complicated analysis, or we need to be in many different places at the same time, and we can't collect those data by ourselves. So they will design what they think is the optimal experiment, and they will analyze some of the data themselves, and they will normally take on responsibility for writing papers and things like that. Where the citizen scientists come in is that they take the role of actually collecting some of the data. So this is the case where, for example, people go out with their mobile phones into I don't know, the countryside, and they're taking pictures of plants and animals, and they're uploading them to the web. Potentially they're analyzing them on some sort of web platform, but ultimately they are providing the data, and then the scientists are analyzing it. So I mentioned before, I work under the auspices of STFC, and STFC, we work with these space telescopes that cost billions of pounds. So it's highly unlikely that a member of the public is going to have a £1 billion facility in their back garden that they can go out and collect the data with. And so actually the type of citizen science I'm going to talk about today is the one on the right-hand side, okay, which is really more of a crowdsourcing type of citizen science, where the only thing really that's left for the citizen scientists to do is to analyze these complex data that have been collected using these very expensive instruments. And so what I want you to think of citizen science as is really as a powerful data analysis tool that you can use to analyze large amounts of data in a complex way that you wouldn't be able to do automatically very easily or by yourself because there's just too much of it. What I don't want you to think of it as is just some tool for outreach. I mean, one of the great benefits of citizen science is that it is a good way of engaging members of the public in your research. So it can be used as a tool for outreach. But primarily, the goal of citizen science is to do scientific research and to analyze data. I want to qualify a previous statement. So I said it was a powerful tool for analyzing big data. These days, we have to qualify a little bit what we mean by big data. Big data now can be billions or hundreds of billions of data items. Even with millions of volunteers analyzing those data for you, that isn't tractable using citizen science. However, let's say you have 1 million data items or 100,000 data items, then citizen science is a really powerful tool to do that analysis. That kind of leads on to the next elephant in the room, if you like, which is a question I often get asked is, do we really need citizen science in the age of machine learning? Do we need human beings to be spending their time and effort looking at images, looking at videos, listening to audio, when we've all seen on the internet that machine learning, also sometimes called AI, can do these amazing things. So it can have superhuman performance at detecting faces or telling cats from dogs and things like that. Well, the truth is that machine learning is an incredibly powerful analysis tool, but it's only a powerful analysis tool if you have a model that's been trained to do the task that you're trying to do. Okay, so a machine learning algorithm, we call that a model. And it may well be the case, if you're doing a novel piece of scientific research, that a model that does exactly what you want to do doesn't exist. Okay, and it used to be the case that was argument enough for citizen science. You would just say, well, machine learning could have done it if there was a model, but there isn't a model. Nowadays, mainly thanks to industry, if I'm completely honest, turns out actually training a machine learning model, making your own machine learning model and training that is quite straightforward now, as long as you have the data to be able to train it with. So one of the downsides of machine learning, or at least a lot of types of machine learning, I don't want to get into the technical details, but there are ways to get around this now if you are very tech savvy, is that they need a lot of labeled data in order to be able to learn the task that you want them to do. They need far more labeled data, in fact, than a human being would. So if I wanted a machine to be able to tell the difference between a dog and a cat, I would need to give it 10,000 examples of dogs and cats. If I want a human child to be able to tell the difference between a dog and a cat, I need to give it 5 examples of a dog and a cat, and they will be able to do it. Okay, so one of the big things that you're going to come up against when you're doing your research is, where can I get my labeled training data from? Well, that would be an easy thing to do if somehow you could find lots of willing volunteers all around the world who were enthusiastic about your science and were willing to do it for you. And of course, that is where citizen science comes in. So I now want to tell you about the primary platform that gets used by STFC to do citizen science. And apologies if I now start to sound like an evangelist. The truth is I am an evangelist for this platform. I think it's really good. One of the main benefits of this platform, which is called the Zooniverse, is that it is completely free. So it's going to cost you absolutely nothing. You don't need to hire a developer to build you a nice citizen science platform. The Zooniverse will handle all of that for you. So what is this thing called the Zooniverse? Zooniverse is a very popular platform for what's called people-powered research. And it is designed to implement that model of citizen science that I've been talking about, that crowdsourcing model of citizen science, where you provide the data and the citizens will analyze it for you. It's a really feature-rich online tool, and it's host already to over 200 very successful citizen science projects. I've talked mainly about astronomy so far. However, Zooniverse is not just restricted to astronomy. It's a really powerful tool, and of those 200 projects, those 200 projects exist in many, many diverse fields. So just to illustrate that point, this is a timeline of the number of projects that were hosted on the Zooniverse platform up until 2018. So it's a little bit out of date. But what you can see is, first of all, the increasing popularity of citizen science and the increasing popularity of the Zooniverse platform over that time. But also you can see the wide range of different scientific topics that are being investigated using the platform. So that includes things like space, my favorite one, ecology, biomedicine, humanities, all sorts of things, many, many more. And of course now food as well. So hopefully I want to convince you that Zooniverse is the tool for you. So let me try and do that a little bit more. What's in the box? Well, I don't know where 200 came from, but there are 2 million volunteers all around the world. Obviously, there's a typo there, who are really, really enthusiastic and wanting to get involved with scientific research, and who are there to help you to do the research that you want. The Zooniverse team themselves, of which I'm sort of a satellite member, they are extremely helpful, very friendly, and together their combined expertise is absolutely enormous. So they know a lot about the best practices of citizen science. They will help you to design your project to make sure that you get not only good data, but also you keep your volunteers engaged, keep them excited, and hopefully they get through your data quicker because of that. The nice thing about Zooniverse as well is that it's a platform that's constantly improving. So first of all, it's all open source. They actively invite people with the skills to help contribute to the development of the platform. What it means is that there are new features appearing all the time. So if you go to the Zooniverse and go, oh, I wish that there was this feature available, well, there is actually an opportunity for you to ask them to implement that feature. And if you are not in the minority, if there are sufficient people who want that feature, then it might well get implemented. What sorts of data can one analyze using the Zooniverse? Well, I mean, this is a handful of the sorts of things that I think most people on this call could categorize the data that they use into. So images is the primary one. There is text, both printed and most importantly, handwritten. I will show an example of a handwritten text transcription project later. You will see why that could be really difficult for a computer to do. Audio, so that's obviously sounds, video, and now numerical data as well. So if you just have some numbers, Zooniverse includes features that will render that graphically. So they will render it as a graph, or they'll render it as a pie chart or a histogram or something like that. So really, really pretty much whatever data you have, you can get volunteers to classify it on the Zooniverse platform. I think really one of the best ways for me to show you what can be done using the Zooniverse is to show you a few examples of the projects that are there right now. So I'm going to do that. So the first project that I want to tell you about is actually the first project that was ever launched on the Zooniverse. This is a project called Galaxy Zoo. We're back to space again. And let me just show you how Galaxy Zoo works. So this is Galaxy Zoo. When you arrive at the Zooniverse, which is zooniverse.org, you will see a page that looks very much like this. And that's one of the big advantages of using a platform like Zooniverse, is that the features that you will see on the page are replicated across all projects. So volunteers can become very familiar very quickly with the task that you're going to ask them to do. So all pages, for example, will have this Get Started button. So you can click on the Get Started button, and it's going to show me a picture of a galaxy, and it's going to ask me a question about it. So it's going to say, is this galaxy smooth? Does it have features or a disk, or is it a star or an artifact? Okay, so it's got these nice helpful pictures to let me guess. Well, quite clearly, this one looks most like these. So I'm going to click on smooth and then click next. And then it's going to ask me some more questions about the galaxy to try and understand in detail what the shape, and we call them the morphological characteristics of this galaxy are. Now, one of the interesting things about this is that depending on the answer that I'd given for the first question, if I had said, no, it's not smooth, it has features, I would have been asked a different set of subsequent questions. So let me just illustrate that. That's what this looks like. So you can with Zooniverse, you can build a very complex analysis in the form of something called a hierarchical decision tree. So what you see is, depending on what I'd answered for the first question, I would have been presented with the subsequent question that I was presented with, or I could have been presented with a different set of questions, a much more complicated set of questions, because if there are features in the galaxy, then there's much more detail to be gained from that image. And so this is a really useful thing. You're not wasting volunteers' time by having them answer all of these questions when they don't pertain to the particular image that they're looking at. So that's Galaxy Zoo. Galaxy Zoo is one of the most popular Zooniverse projects ever. To date, over 1.5 million objects have been analyzed using Galaxy Zoo. It's also one of the projects that's pioneered a lot of the new technologies in Zooniverse. So Galaxy Zoo is now integrated with a machine learning engine that was originally trained using the labels from Galaxy Zoo and is now used to pre-filter the images that go in, so that ones that aren't very interesting for volunteers only get shown once or twice, just to confirm that the machine hasn't made a terrible mistake. In general, however, because we're showing these images to non-experts, okay, we don't just want to rely on the response from one person to get the answer. So what happens in most citizen science projects is you'll collect a number of responses about the same piece of data, the same image in this case, and you will aggregate those together. And Zooniverse has a lot of powerful tools now to do aggregation. And again, the Zooniverse team has a lot of expertise, and they can help you to set up your aggregation chain. And of course, I can do that as well. So let me just jump back to my talk and tell you about another project. This is a different project, not from space this time. This is an ecological project. It's called Battling Birds. This is actually the Panama edition. I'm going to show you the original Battling Birds. And the idea of this project, if I just jump across to it, is it's going to show you videos now. So the subjects in this project are videos. And what they want you to do is classify the behavior of these birds. So they're going to ask you to count the number of birds. They're going to ask you what the birds are doing. They're going to ask you what types of birds they are. And they're also going to ask you, are the birds chasing each other off this bird box? Now, counting birds, yeah, that's easy. Describing behaviors, that's reasonably easy. Actually saying what the birds are is really difficult. So Zooniverse has built in this tool called the survey tool, which makes it really easy for people to do taxonomic analysis of very complex typographical systems, I suppose. So they can tell the difference between many different types of animals that they've maybe never seen before just by using this interface. So first of all, let me just play the video just to prove that works. So we've got a couple of birds here. So the first thing is, were there any birds present on the platform or feeders? Well, yes, there were. So we'll say yes, we'll go to next. And then this is the bit where we get the opportunity to identify all of the birds that we've seen. Okay, and first of all, you get a series of images to choose from. If I click on one of those, I then get many more examples of things that they might have looked like. So I can go and say, it might look like this, it might look like this, it might look like this. And then I can say, well, I've seen a certain number of them in the project. However, I don't think it was that one. So let me cancel that. I think it's probably this. Ooh, maybe. Anyway, and we do that. And then we go identify. And then we go on to the next part. And then it's saying, were there any displacements? Well, the answer to that is no. A displacement is where a bird comes in and scares away another bird. So the answer to that is no. I click next. Is it raining? No, it's not raining. Done. Okay, and then we're on to our next subject. So what we've done there is we've answered a series of really quite difficult questions about a topic that, frankly, I've got no idea about. But I've been able to do it just because of how easy it is to set up a project like this in the Zooniverse and to interact with it. And then the final project that I want to tell you about is one, this is basically a new set of technologies that have recently been introduced to the Zooniverse, specifically designed at text transcription projects. Text transcription is a very difficult thing for a computer to do, particularly if it's handwritten text that's being transcribed, and even more so if the text is archaic or on old paper or the paper has holes in. In fact, to be honest, it's quite difficult even for human beings to do. But again, Zooniverse has built in the tools that allow you to do that. So let me show you an example of that. This is a project called Corresponding with Quakers, where you are invited to transcribe documents from a corpus from the 17th century around the time of abolition. And this is a corpus mainly by a woman called Mary Ledbetter, who was a poet, and a lot of her documents give a very unique insight into the female perspective around this time of abolition. And so what this interface allows you to do is it allows you to, first of all, search through the documents and find any lines of text that haven't been transcribed. On this particular document, all the lines of text have been transcribed because they've got a little line underneath them. These lines are all gray, so that's telling me immediately that the transcriptions are completed. Now, if you're looking at this, and certainly when I first looked at this, you would have thought, well, this is really difficult. I mean, I can read English, but I can't really read this handwriting. Well, there's a feature built in that will sort of let you get your eye in and let you learn to read this. So what you do is you click on the line and it actually tells you what the current translation is. So it tells me Rose and her daughter Betty. And then I can look up here and I go, oh yeah, I can see that is Rose and her daughter Betty. And then you slowly go down and that allows you to learn while you're doing the classification, how to perform better. We jump to the next page of this document. And what you can see here is that here's a line that hasn't been completed, so it's still pink. And when I click on that, it allows me to insert my own transcription. So I think I agree with the current consensus, which is that I have a child. So I'm just going to write that I have a child, and then I can save that and close it. Okay. And so if I've done that, maybe I've completed the transcription, never know. Okay, so once you've done that, let's say I've finished doing my transcription. The answer is no, so let me just quickly finish this one. Yes, I agree with that translation. Save, say yes, let's click and let's go on to the next part. And then I get to assign a tag, if you like, assign a classification to this document, potentially one or more. What are the topics of this document? So this is a way not only for the researchers in this case to have some really complex handwriting transcribed into digital text, but also to have at the same time a human being use their intuition, their knowledge of the world to be able to assign a sort of an abstractive summary of what the text is about. So I don't have time to do that because I haven't had time to read this entire document. But hopefully what you can see from this is that this is an extremely powerful tool. If as a food scientist, you have documents that you would like to be transcribed somehow and analyzed in some way, hopefully you can see that this tool would be a really powerful way of doing that. Okay, so those were the three projects that I really wanted to showcase. Let me move on a little bit and talk about something else that I think is really good about citizen science, which is that it's all very well for the scientists, again, in this crowdsourcing mode of citizen scientists, to design an experiment, believing that they know exactly what the data contain and what the most important thing in the data is. But actually, one of the great things about citizen science is that often you find these serendipitous discoveries where the volunteers find something in the data that you didn't think was there or you didn't expect, and they tell you this is interesting. So again, I have some examples from astronomy of this. From Galaxy Zoo on the left-hand side here, the target galaxy is the one at the top. Okay, so we were asking the volunteers, take a look at this galaxy, tell me if it's smooth, tell me if it's featured, answer all of those questions. But then some of the volunteers, well, they saw that, but then they also saw this thing down in the bottom, and they're like, what on earth is that? And it turns out that this is a really remarkable thing. So what's happened is at some point in the past, some gas has come off this galaxy and collected down here. And then a black hole in the middle of the galaxy has started accreting matter onto it, shot out high velocity particles, and then reheated this gas to make it glow this green color. Okay, this was completely unexpected. Scientists did not expect to find this. This was found and highlighted by a citizen scientist. And now, of course, now that we know they're there, we find them everywhere. Okay, so that's a great find from citizen science. Similar thing happened on the right-hand side. These are a special type of galaxy that got given the creative name green peas. Okay, again, we were looking for galaxies that look like this. If I designed an automatic algorithm to look for galaxies that look like this, it would never find these. It would think that they were stars or some artifact in the image or something like that. Human beings they don't need to be given precise instructions. They can extrapolate from what they've already seen, and they can do the work of discovery, of actually finding new and novel things in your data for you. And I think that's a fantastically powerful aspect of citizen science. One more example that might be familiar to you if you pay any attention to astronomy at all. A few years ago, there was a big furore in the press where a star was discovered that seemed to have a strange dimming behavior. And you don't have to understand what this graph is. It's basically saying that the star's brightness dropped very rapidly for short periods of time. And that's really unexpected for a star. And if you remember this at all, you remember that everyone immediately decided that we'd discovered an alien megastructure surrounding this star, and the press went crazy. I hate to spoil the excitement, but it turns out it's probably more likely to be something just like dust from some comets or something around the star, which is a much more mundane, but still scientifically a very interesting result. Now, the point that I wanted to make about this is that an automatic algorithm was deployed on these data, and it did not find this. Okay, this was found again by citizen scientists who weren't looking for, well, they were looking for the thing the machine was, but when they saw this, they just thought, oh, that looks a bit weird, and so they reported it. So the question is, how did they report it? And again, I'm going to come back to Zooniverse. On Zooniverse, you can report things like this using a set of forums that are attached to every project called Talk. And this is a forum from actually one of my projects where somebody has spotted something in the image. They said, is it a peak to me? And then I write back and say, well, it is a peak, but actually it's not the type of peak we're looking for. However, what if it had been the type of peak that we're looking for? What if it had been something completely new and novel? This is a really great way for me to find out about that. So just wanted to flag that. I think that's a great feature of citizen science and indeed of Zooniverse. Before I move on to actually talk about food, which is the thing that you're probably all here to talk about, let me just highlight one more thing, which is that Zooniverse also has an app. It's available for iOS and Android, and it is very useful for projects that are quick fire. So simple binary questions: is this an X or a Y? Is this a yes or a no? You can process data very, very quickly using this mobile app. I don't have a tremendous amount of time to tell you about it, but I recommend that you go to the best resource for this, which is the Zooniverse blog, where there's lots of information about this rapidly developing app. So development is ongoing on the Zooniverse mobile app all the time. Okay, yeah, so what about food? I want to tell you about two case studies, if you like, two projects that came out of a previous STFC Food Network sandpit that involve STFC citizen science capabilities. So the first one is a team that wants to build a database to preserve something called African indigenous knowledge. I'll say more about that on the next slide. So the leaders of this team are from Brunel University, Stephen, Sam, and Jimena Schmidt. From STFC, there's myself and Jens Jensen, who is also on this call. And we also have some partners from Africa, Jamj Agriculture International and Njala University. So what's this project all about? So there's this thing called African indigenous knowledge, which is really, it's to do with this tacit knowledge, as I've written there, that's held by small communities in the form of the cultures and skills that they've built up over many generations living in Africa. And these are skills that pertain to production of food, the preservation of food, the way that you make food safe to consume. Some of that knowledge only exists in the languages of the cultures that actually possess it. And more than 80% of citizens in Africa, it's believed at least, have this kind of knowledge. But the problem is that the documentation and dissemination of that knowledge is really difficult because of the language barriers and things like that, and because also people tend to think that it's obsolete knowledge, which of course it's not. We're in a world, as you all know, where sustainably producing food is becoming more and more of an issue, and massive agriculture in the sort of Western mode, if you like, or Northern Hemisphere mode, is probably not the best way to do that. So if we can create a database of these skills, then it will be an incredible resource, not only for people in Africa, but potentially also for people all around the world. And so the concept of this pilot project is that they wanted to demonstrate they could build this database, the AIK database, and a platform that would allow scientists and also citizens to access it. So the idea is that we would have this database. It has media resources, things like images, video, audio, and text in it. And they're indexed according to various different types of classifications. So are they about a specific type of food? Are they about a specific type of processing of that food? So for example, harvesting palm oil. And then we wanted to be able to aggregate those results by region within a country. So the pilot project was set up in Sierra Leone. So we want to be able to aggregate those results by the different regions and districts in Sierra Leone. So the question is, where does citizen science come in the schema? It comes in here, right? Because we have these data and we don't necessarily know where all of the interesting, first of all, the interesting things within the images, within the videos are, but also we don't necessarily even know what the videos and images show. For the pilot project, we do because they were collected specially, but in general, we may just be getting data that have been uploaded by, let's say, a farmer working in Sierra Leone on their mobile phone or mobile device or something like that. And we need to find some way to label them. And so the idea is to do that using citizen science. And so let me just show you the project that they've been working on. And what they've done is that they've actually created several workflows. So the projects that I've shown you before, they've all had a single workflow. But for this project, they've identified that it actually makes it simpler if they have a workflow where they ask people to identify the food. So to say where in the picture there is a food, to identify tools that might be in the picture, and then later on to actually give a label to them to say, like, what is the tool, what is the food? So let me just quickly show you the identification workflow. So here are some palm fruits, okay? And what it's saying is draw a rectangle around where the foods are. So let me just, well, I could do it around each individual one if I wanted to, but instead I think what I'll do is I'll draw a rectangle around all of them to make it simple. And then I click done, and then I click next, and then it's saying, okay, more food. So then I can again click it around here like that and click done. Okay, next. Okay, let me jump back and quickly go onto the tools one. So again, there aren't any there aren't actually any tools in this, so I don't have to click on anything. I go to the next one, click done. And here, let me just assume that that's a tool. Again, I can just draw a box around the tool and click done. Okay, so this is a way now, not just of collecting the fact that there is a tool in the image, but actually collecting positional information, a label for where the tool is in the image. And if you know anything about image analysis, machine learning algorithms and things like that, that's exactly the sort of label that they need to be able to do this automatically. So at the moment, this is a small pilot project, but the ambition is to have this project become Pan-African and potentially international, at which point you're going to have to be processing much larger volumes of data, potentially video data, image data, audio data. And at that point, you're going to want to have some way of doing it automatically. But in order to train those machine learning models that can do it automatically, we need this citizen science step to be able to provide those initial labels. Okay, so this is, I mean, I really love this project. I think it's really worthwhile, and I'm very excited about it. And they've made great progress on their citizen science side as well. So the next project I want to tell you about, done the quick demo, that was fun, is actually one on text analysis. And the idea of this project, which is led by Laura Wilkinson from Swansea, with various other collaborators, and again, myself and Jens from STFC and Eric Atwell from Leeds. The idea of this project is to try and find some way to predict how a food shock or a shock event, something like the COVID-19 lockdown, will affect the way that consumers behave. So are they all going to rush to the shops and buy tons of toilet paper, for example, or are they going to, buy all of the frozen and tin food they can find? can we predict how that's going to change? And in particular, can we predict it in advance using the sorts of things that they're posting on social media? And in particular, can we use tweets to do that? It turns out this is really challenging. I mean, if you're on Twitter and you've read tweets, you know that the language is not like normal English. It's extremely terse language. It can be very ambiguous, often includes things like sarcasm, and machines find that really difficult to interpret. You know, as an old man, I often find it very difficult to interpret as well. Often it's hard to even be sure if people are talking about food or something else. So the goal of the Citizen Science Project is to take these tweets that have been pre-filtered by a machine, a sort of rough machine, to find things that we think might be about food, and then filter them to find the ones that genuinely are about food, classify them to say, what is it about food that they're saying? So what process? Is it buying food? Is it talking about the process of cooking food to ensure it's healthy and things like that? And then finally label the parts of the text that pertain to that particular activity. And ultimately, potentially not in the scope of this pilot project, but ultimately these are the types of labels that could be used to train a machine learning model that would understand these tweets really well. Okay, so let me show you very quickly what that project looks like. So again, let me just quickly go to get started. And on this project, so let me just have a look at this. Nailed it. This as well as not downplaying what is rich for some. It reminds me of English paper Q a few years ago. Describe a busy place, and some wrote about Asda and got marked down for lack of imagination. So yeah, not about food. I think that made it into the corpus just simply because of the word Asda. Okay, so I'm going to say no and go to the next one. The low of the day, I had to beg the Chinese supermarket for tofu. So this one is about food, but tangentially. So I'm going to tick yes, but then later on, we would then classify this as being about buying food. Okay, and again, this one not about food. Okay, so that was one example. Let me see if I can find another example. This is the workflow where we're asking people to actually annotate where in the tweet the words about food are. So food purchasing, actually this one doesn't really contain anything about food. I've just seen a woman in Sainsbury's wearing a mask. Shrug. Okay, so actually there's nothing here, so I'm just going to click done. Yesterday I bought some peanut cookies, food types. Let me just go peanut cookies and select food types. I'm pleased to report they're cheap, dirty, and thoroughly enjoyable. I found a fragment of one on the kitchen floor this morning, and yes, I did have it for breakfast. Okay, on the floor. Food preparation. Okay, good, done. So again, hopefully I've demonstrated just by going through a few of these things that these tweets are a little bit ambiguous, quite difficult to understand, even for me, and definitely for a machine. So again, citizen science is a very powerful tool to be able to analyze a very large amount of data reasonably quickly by having lots of people look at it at the same time. That was a quick demo. So just to conclude, I've shown you lots of projects that were built on the Zooniverse. And I want to talk about one more thing, which is, I think, possibly the primary strength of Zooniverse, which is its project builder interface. Again, Zooniverse is completely free. So if you want to build a project on Zooniverse, all you need to do is go to zooniverse.org/lab, and you can build a project. And what you will come to is something that looks like this, which is just a nice web interface where you can set up your workflow. So actually, this is the workflow from battling birds that we saw earlier. And what you can see is, if you remember, that workflow was pretty complicated. They've just set up a set of tasks within the workflow that look like this. So they have the question task, then they had that survey. So what was the type of birds? Were there any more displacements? We skipped that because none of the birds were displaced. And we also skipped these. So again, we truncated the workflow, which is quite nice. What does that look like in practice? Let me just click on. So you have a question task. Let's go back. We have a question task. That takes us on to a survey task. That takes us on to well, this is still part of the survey task. Once we've done that, then we can confirm the survey task, and then that would take us on to another question, and then we would go around the thing again. And so what you've done is you've set up what would be a very complicated thing to do if you had to develop that web logic yourself. If you had to write the JavaScript yourself, or if you had to write the HTML yourself, that would be quite a difficult thing to do. You've been able to do that in this environment at the same time as providing things like help text over here on the right, the question text, the answers, and things like that. So that's one of the things that if I'm evangelizing about the Zooniverse, which I am, this is the thing that really sells it to me, is that you can build a project. I've seen it done in 5 minutes. Somebody just get their data up there, project built, done, 5 minutes. Okay, so I just want to quickly summarize. I think we're getting towards time. Citizen science, I've said, I think I want you to think of citizen science, at least in the STFC context, as a really powerful data analysis tool. Okay, so it's a tool for analyzing large amounts of data. I pointed out that even if you think you know what's interesting in your data set, citizen scientists might find something that you weren't expecting. So citizen science is a great way of engineering serendipity, if you like. I hope you can take away that there are millions of volunteers around the world, maybe not 200 million yet, but 2 million at the last count, who are eager to help you with your research for free. Zooniverse itself is free. The project builder is free. And finally, citizen science is also key to ongoing projects that are funded by the Food Network. And so I will stop there. I'm just going to tell you about some more resources. Hopefully these slides will be shared at the end. So these are resources. If you want to learn more about any of the things I've told you about, go to these links. And of course, you can email me for more information as well. So I'll go back to the summary and take any questions that anyone has.